Hi guys, you are welcome to Genius Ideas. In this video, we are going to be talking about Python data types. Okay, Python supports a variety of data types, allowing developers to work with different kinds of data in their programs. Okay, so these are some of the common data types that we have in Python. The first one we want to talk about integers. Okay, integers. So whole numbers without any decimal points in summary. Okay, whole numbers without any decimal points. And examples, you can do something like x equal to 5, you can do number equal to 7, you can do something like age equal to 25, you can do anything that is a whole number. Basically anything at all that is a whole number, then it falls under the integers data type, and the constructor is the int. In the int, this is the data type. For example, if I want to print x, for example, if I should run this program now to print x, you see that it is giving me 5, which is what it's supposed to give me. But there is this type, function in Python that can be used to print the type of a particular data. For example, if I should print x directly the other time, it is giving me the value of x. Okay, but me printing the type of x, it will give me the data type of x. If I should run this, you see that I'm getting class int. Okay, you see that I'm getting class int. So all these data types that we have over here, they fall under integers. Okay, so the next one that we want to talk about, the floats. So these floats are numbers with decimal points, or they are in exponential forms. Okay, two type of representation that we have for floats. They are numbers with decimal points, or they exist in exponential form. A good example is pi, which is equal to 3.142. Okay, so and another example, you can have something like maybe a value equal to say 2.5 exponential 3. No, exponential 3. So if you remember your standard form in mathematics, this is the same thing as 2.5 times 10 raised to power 3. So this should be giving you 2500 if you should print it. Let's try it out. So if I should come here to print, if I print pi originally and I run it, I'm getting 3.142. If I should print the type of pi, it will be giving me, you see, class float instead of class int that I was getting initially. Now let us print value. Okay, print value. So run this one. You see that I'm getting 2500. Okay, let me clear my terminal. So if I should print value, you see that I'm getting 2500. I'm getting 2500.0. So this point 0 is what signifies that it is a float. All right, the decimal point over there. So the next data type we are going to be talking about is the strings, the str. So the string is an ordered sequence of characters. It is enclosed in single or double quotes. Okay, so strings. So you can have something like say message equal to hello world. You can see that I enclosed this one in double quotes. So let me give an example. Name equal to Genius. Both of them are valid Python strings. Both of them. If I should print message, okay. If I should run this, you see, I'm getting. Let me take this one out. So if I should print message, you see, I'm getting hello world. Okay. If I should also print name, run this, you see, I'm getting Genius. If I should print the type of name and I run it, you see I'm getting class str clear. If I should run this, you see I'm getting class str. So that is string for you. So we also have this boolean, which is a two-state data type. okay, which is a two-state data type. We call it a two-state data type because it can represent true or false only. Okay, true or false. So no, so booleans. So these booleans, I can do something like is admitted equal to maybe true. Okay. Another example is maybe status false. Okay, this might be a medical test or something, so the result is usually true or false. So that is it basically. These are the two possible values you can have for booleans. It's a two-state data type that represents truth values. Okay, it can be true or false. For example, boy or girl. If it is not a boy, then it's a girl. If it is not a girl, then it's a boy. The same thing applies here. If it is true, then it is not false. If it is false, then it is not true. All right. So just two state data types. If I should come here to print status, so if I should run it, you see I'm getting false. So, but what if I print the type of status? If I run this, you see I'm getting bool, bool. So that is the type of data. I think this one, the constructor is str. This one, the constructor is float. While this other one, the constructor is int. So please take note. So this one is bool. Okay. So now, all these data types that I've explained before now, the integers, the floats, the string, and the boolean, we refer to them as primitive data types. Okay. One of the reasons why we refer to them as primitive data types is because they can store one value at a time. They can only store one value at a time. One other primitive data type that we have in Python is the complex data type. Okay, the complex data type, but I don't use it, and most developers don't actually. So the complex data type, it is when you want to work with complex data, especially in scientific programming, that is where you use it extensively. So I'll just leave it out for now. Like I said, all these data types that we have at the moment, we call them primitive data types. Now let us talk about some other data types that we refer to as Python data structures. You can call them Python inbuilt data structures. I've seen some materials that refer to them as Python collections. Okay, Python collections. So the first Python, let's say data types. If you want to call them Python collections, you are still correct. So the first one we are going to be talking about is lists. Okay, lists. So lists are ordered mutable collections that can contain elements of different data types. Okay, all these data types that we have over here, a list is a collection of elements, can be of different data types, and they are ordered. So this is what you can do something like numbers equal to, you use this symbol over here to create a list. Okay, so you can have something like 1 3 22 7. You can even add a name. Let me say Chuck. Okay, so Gilbert. Gilbert. So you can just a list of items. They can be of different data types. Basically, that is what a list is. So all these data types will be treated individually. Okay, they will be treated individually, and I'll be as detailed as possible. But for now, I'm just introducing all of them. So you can also have a list of names. So for example, names of friends. If you watch my tutorial very well, you know that my first friend is Alexander. So let's talk of Samuel, maybe Daniel, then maybe Adiza. So just a list of names. They can. What I'm trying to explain here is that your list can contain the same data types, and it can also be the same data types, and it can also contain elements of different data types inside the same list. All right. So that will be list for you for now. So if I come here to print numbers, save this and run this, you see what I'm getting. So, and if I should print names, run it, you see I'm getting my names. Let me clear. So what if I want to print the type of names? You see it's giving me class of lists. Okay, the constructor of this one is list. So the next one we are going to be talking about tuples. They are similar to list, but they are immutable. Once you create it, elements cannot be modified. Okay, they cannot be modified. Once you create it, you cannot modify it. In the case of the list, you can modify it, but when you create a tuple, you will not be able to modify it. So a good example is maybe numbers. I'll call this one tup. So let me, you use parentheses to create your tuples. So you can see number stop. So 1, 3, 22, 7, Chuck and Gilbert. So this data that you have over here, you cannot modify it. You cannot modify it. That is the major difference between the tuple and the list. It is when you are looking for immutability. Okay, when you are looking for that immutability, you are restricting access to be able to modify data. That is when you use a tuple. Okay, so I can come here to do something like this. um, Let me say print numbers top. Save this and run this. You can see that, you can see what it's giving me. I cannot modify this, but don't worry, when we treat tuples you will understand it better. So let me say, let me use arr. So arr. So let me come here to print the type. If I want to print the type, if I want to print the type, run this, you can see I'm getting my tuple. Okay, you can see I'm getting my tuple. So the next thing I want to do now is to talk about sets. Okay, talk about sets. So sets are unordered collections of unique elements. Please note that, unordered collection of unique elements. Okay, unordered collection of unique elements. So you can have something like unique numbers equal to, then you have a set. You use these curly braces to define a set. So if your set has only one element, you can write the element, then you put a comma here. Okay, this is how you define an element with just one set. A set with just one element rather. So I might have something like 1, 3, 4, 7, 9. Okay, so sets. Okay, so and the constructor is set. So these are unique numbers. If I should come here to print unique numbers, please take note of something. Let me clear my console so you'll be able to see it better. If I should come here to run this, you see that I'm getting 13479. Okay, I'm getting 13479. I'm supposed to be getting, okay, yes. So you can see what I'm getting now, 13479 unique numbers. Okay, unique numbers. So if I should come here and add another 4 for example, and I run this, you see that it will never give me another it will never give me this 4 twice. Okay, it will filter out all the excess. It will filter out all the excess. So one trick is that if you have a list that has contains multiple elements of the same type, the same data, you can convert it to a set. Then the set will filter out all the duplicates. Then you take it back to a list. It is one shortcut way to do it. So another thing, let's do something like letters equal to sets. Then maybe hello. Take a good look at what will happen now. Letters. So if I should run this, you can see what I'm getting. You can see it will filter out, it will basically filter out the the excess, it will filter out the duplicates. Okay, let me clear this. If I run this, it will filter out the duplicates. Run it again. You can see that, like I said in the beginning, they are unordered. They are unordered collection of unique elements. There is no order in particular. If I should run this again, I run this again, you can see there is no order in particular for all of them. This is starting with O L H E H O L E O H E L H L O E. There is no order in particular. They are unordered. All right, they are unordered. So that is it. Then we have the dictionary. The last one that we are going to, okay, second to the last actually, the dictionary. So this dictionary, I think it's dict. Yes, dict. So this is an unordered collection of key value pairs. In the case of the set, it's an unordered collection of unique elements. In the case of dictionary, an unordered collection of key value pairs. And you cannot have multiple keys in the same dictionary. One will override the other. The most recent key you added will override the previous key. Okay, so I can have something like person, then equal to, let me say, I can have something like name, and the value of name is going to be maybe Gilbert. Then I can do something like age, then the value of age is going to be 24. Then let me say age is supposed to be this. So then I can have maybe let me say job, maybe I wanted to write cleaner, but God forbid forgive it. So hopefully give it won't see this tutorial one day. So the next one, job, I can do something like let's just say coder. So I have person, name, age, job, and these are the values. This is a Python dictionary. Okay, this is a Python dictionary. If I should come here to print my dictionary, I can just print person, save this, and run it. You see what I'm having over here? Let me clear my terminal. Clear. So come here and print person. You see, I'm having name Gilbert, age 24, then job of coder. So this is what a dictionary looks like. This is what the dictionary looks like, and this is the constructor. So if I should print the type of dictionary, you can see it's giving me class dict. So the last one that we want to talk about is the non-type. Okay, the non-type, we rarely use it, but if you want to create a null data type, you use the non-type. In JavaScript they have something like null, but in Python what we have is none. Okay, so none is what is available in Python. Then you can do something like let me say the non-type. Okay, and everything about it is just none. So it represents the absence of a value or a null value. Okay, this represents the absence of a value or a null value. You can do something like results equal to none. Okay, so if you want to print results, if you want to print results, you're going to be having none. Okay, if you want to print the type of results, guess what? It's giving you class of non-type. Okay, it's giving you class of non-type. So those are the data types that we are going to be treating for now. These data types provide flexibility and versatility in handling various kinds of data in Python, and understanding how to use and manipulate these data types is fundamental to writing effective and expressive Python code. Okay, so that will be all for this tutorial. Thank you very much for watching till the end. Don't forget to like the video and support the YouTube channel by giving us a subscribe. That will be all for this tutorial. Like the video, subscribe to the YouTube channel. If you have any comments, please, you can just use the comment section to let us know about it. So thank you very much. I'll see you in the next tutorial. Bye for now.